All right. I think it's a good time to start. Thanks very much for coming back in promptly after the coffee break. Did you manage to get a coffee, or was the queue as bad as it was this morning? Yeah, some nodding faces. Some people really striving for coffee here. All right, we are Tag and Bernd. We work for IBM. I'm based out of Singapore, and I cover Asia Pacific, and Bernd is based out of Melbourne here. We've got a pretty fast-paced workshop for you today. We're going to go through a number of capabilities pretty quickly, so don't get too distracted. Put your phones down. You're going to see a lot of different features. And the theme of what we're going to talk about today is successes that we've seen in our customer base in adopting API management capabilities, whether it is IBM-based or other vendors. And really, we want to highlight why API management is important. And Matthias this morning talked very eloquently about a composable API strategy, how APIs are the building blocks of that digital transformation. And he talked about things like integration platform as a service, the idea of treating APIs as products, the idea of having automation and using artificial intelligence to make development of APIs easier. I also want to highlight what happens when you sprawl the number of APIs that you develop and you don't have a solid API management strategy. You lack that product lifecycle management, that governance that makes your API easily adopted. You lack visibility of what APIs endpoint you expose. And that can lead to security, potential security threats. We'll talk about it in more detail later, but API security attacks are the widest attack surface today for any IT-based security attack. So what are those 5 key things that we see our customers doing well when they're successful at what we call multi-form API management? Obviously, API development. Matthias talked about this in very eloquent details, how you make APIs composable and reusable. We're going to talk about what technology can do to make API development easier. A solid API testing strategy with the number of APIs we've got out there, it's becoming fundamental. Governance and lifecycle management, as I mentioned, but also what we call API observability, which goes beyond that analytics that we've talked about so far and looks into what an API does when it trickles down into your systems. And finally, as I mentioned, one of the biggest topics out there is API security and what we call dynamic API security. Now, I haven't mentioned AI or large language models here, but it is true that all of that stuff is coming to aid us across all of these different dimensions. And to be fair, outside of the API space, in the IT realm, everywhere, using things like generative AI, ChatGPT-style large language models is making the job of developers and IT operations people much, much different. And we're going to see how that fits into an API story. All right, without further ado, rather than me talking about these things at length, which I'm going to do at 1:30 today in this room, by the way, if you want to hear me talking more, we're going to show you now in this workshop. We're going to start with API development in particular. We're going to focus on a number of things, from integration platform as a service, low-code, no-code tooling, but there are 2 things that I want to highlight, which is how are we going beyond REST? SOAP and REST have been what have made APIs popular, but there are a couple of different technologies and technological initiatives that are expanding the reach of APIs. One is GraphQL, still a synchronous protocol and data format interface, which allows developers of applications to query HTTP endpoints with something that is similar to a structured query language like SQL, so that you don't have to create multiple RESTful APIs. You can have one API endpoint and ask the amount and quantity and type of data that you want to that endpoint and retrieving it. And Gartner predicts that by 2025, 50% of people that have got APIs will have GraphQL in production. The other end of the spectrum is the asynchronous world. How can we expand the reach of our data beyond synchronous request-response interaction patterns? We're talking about messages, we're talking about events in the Kafka style, and the specification called Async API, which is the sister project to the Open API specification to describe how you can consume asynchronous endpoints. So we're going to talk about those in more details, but without further ado, Bernd, do you want to come and show us something?
Yes. All right. Well, Welcome from my side as well. We're going to talk about API development now in the context of a multiform API management solution. And yes, this is the start screen for the API manager for our API Connect, and it shows you the key entry points into developing APIs products, catalogs, managing the resources. But for this case, for the demo API, we're actually going to use something that is built as a true integration, for example, with Salesforce. So it is easy to use from our end different components like app connectivity and build basic integration flow that is exposed as an API, handed over to API management, and that way have basically an integrated way to build integrations alongside with APIs there. So I just built this integration just to give you some real context in the end of the day. Once it comes up here, because it's pulling information from Salesforce in a flow, just a set of leads that you're requesting, not with a lot of complexity, but with some real data. So this solution helps you to build something like that is sitting behind a API solution, retrieve leads from Salesforce, and then it helps you. This is the first entry point here for AI assistance. It helps you with the mapping of the data model against your connector data model, and you nicely have a typical object structure for first name, last name, lead ID, email set and ready to go, which we can then consume as an open API specification. That means you can nicely go ahead and export that. You can do it straight in the UI, but we want to do the path of having an external API. You can export it as an Open API version 2 and version 3 specification, and from there you can start working in the API manager. So just to move ahead, we're going to import an API. You can see here in our healthy demo system, there's already a couple of nice multi-form APIs running here in different versions, in different types and flavors. And we're just going to add another API in this case. And you can see how this system supports different APIs, obviously, from the specification side, version 2, version 3 open API. And you can nicely go ahead and not only work with web services as a proxy or convert them into REST API without any interaction, or use GraphQL APIs, start from scratch, or as in our case, we're just going to use an existing open API. We're going to upload it here from our system. That was the Salesforce leads one. Give it some credentials if necessary, and then basically we have a good start to work with the API. Have it in the system in the API manager, and the, let's say, form-based visual representation of our API, where you can see the contained schemes that we're using, the data path. So it's very simplistic. It's just a list of leads. When you call leads here, you can see you can now tap up and add API-specific policies to do policy-based API management for transformation, for security policies, and different things like rate limiting, etc. We could just add to it and select a specific plan if you wanted to. In our case, we're just going to move ahead. We're going to publish the API to our gateway, to the catalog, and then we can go ahead and test the API. Testing is actually here with a built-in test client. That is almost a similar thing like Postman. You get the listed operations here. You can quickly test against it and get responses and feedback. Obviously, if you need more information for the header parameters or input parameters, you can add them here certainly. But you can see here, right, we got a positive response. The lead objects are coming back, and you can see we get a proper data set of people and leads that are coming straight from Salesforce. There's also additional things like tracing in here, so you can nicely see a full trace of that operation that happened here, and delve into details that you normally only could pull out of the gateway log. But it's made accessible here for you to quickly work and debug with these APIs here. You can see how it's running through your API assembly that we just saw. So the rate limiting, and then doing the invoke to the backend system, the memory usage, the latency potentially to already help you see if there's something that needs to be added. And then lots of additional information that you can use or just simplify for tracing purposes when you're building APIs. That's easy. You can also take a look at your experience you would get in the developer portal. You can try the API here from this perspective. This is a simple callout, so no input parameters. We're simply pulling information from leads. So that's the request that's being built, and then those are the responses in a bit more formatted fashion as they come back from your API gateway. That's the first use case. The second one in our multiform API management concert use case will be a GraphQL API. So GraphQL is a new API standard that allows you to treat an API more like almost like a database. So it has a query language against it, almost like SQL. So you can do very comprehensive queries and really in a single query specify out what data pieces and elements you want to get back and do your comprehensive filtering and basically build up of the data model. As opposed to a REST API, which is a very chatty communication to your API backend and allows or requires quite a few calls to get a set of data elements and pieces out of a backend system, whereas GraphQL can do a single query very comprehensively that way. So GraphQL is something that is a first-class citizen in our API manager as well. So we're just going to select GraphQL here from our list, move on in the wizard, and then just give it a name. So we're going to use the Star Wars API here, call it demo swappy. The GraphQL server is right here, and then we're just going to move on. That's all the information we need. You can see there's already warnings because GraphQL is a bit different because you can easily put a lot of stress and load on your backend system with a comprehensive query, and you kind of have to know and understand if it's a heavy or if it's not such a heavy query you're doing against your backend, and that's why throttling and rate limiting is a very important topic around this piece here. So you can already see there's a couple of warnings here. We're just going to walk through the wizard for now. Finish it up, edit the API. And you can see that the GraphQL schema, or you can see firstly that a GraphQL API is quite a bit more comprehensive on the API assembly. So there's quite a few things that are happening and a lot of branching. You can see the policy assembly here can be extremely comprehensive and can actually also handle more complex and sophisticated APIs like GraphQL. But what makes it a native citizen is that we can nicely basically add weights and cost to the specific elements in the GraphQL schema that you see here. So this is the schema that we imported, and you will see there's quite a few warnings here on pieces that should be optimized so you can handle it properly. This can be sometimes recommendations for the weight, but it's also just configuration of your APIs so that you have a level of control of the load that you're putting against the backend system. I'm just going to accept all the suggestions here. I'm going to add and enhance the weight here a little bit. You can see, for example, for the film subcomponent or list, you can add different weights. And for the films themselves, let's add this to 4 and an assumed size of 1. And that is more or less the way that you walk through the weighting of the different elements to provide you a means to effectively control and work with the schemas here. All right, we're going to save it away. And now we can publish the API just with a test product or a temporary product. And once it's published, we can test against the GraphQL. Okay, so we also get a test harness for GraphQL, as you would expect, similar to what we got for a REST API. I can add my query here. It's actually still in there, and then I can run against the backend system. You can see I did a query against the first 10 films in here, and I get the titles, the message back, the more details on each film, and things like that. So it is a way to really create a comprehensive query and to get a lot of information very tailored and targeted out of the system here. The last thing you would have to do after publishing this would be actually to wrap it into a proper product here. So I would add a new product for this, potentially call it Star Wars maybe. Moving ahead, add my demo Swampy GraphQL API, and then walk through this and work with the plans. So this would be my visibility and subscribability configuration on the developer portal. But I just want to get in here and show you how you can edit the plans, because we already added weights and cost factors to it. But if you add, for example, a specific new plan to it, you can see that there's dedicated GraphQL rate limits, where you can add specific cost models and also specific assembly limits and count limits to which are specific to a GraphQL API. Those would be something where you add, for example, a cost budget of maybe 10,000 for specific field costs and type costs, and that would be something that you would provide per second here in this case, and that is a base rate limiting model you can use against GraphQL, and there's obviously ways to tune it and to use it for controlling the load on the backend system here. All right, you can save it away, you can publish the product, and then the product, including the API, will show up on the developer portal and can be subscribed and consumed by application developers. You can publish it straight from here, and then we should see, yes, let's just put it to the sandbox gateway. Just use the defaults for the visibility properties, and then basically, yes, our new product, Star Wars, that would include the Star Wars API as GraphQL is published onto the gateway. The last piece we're looking at is actually not GraphQL, but it's async API. So it's also very much or very deeply integrated into our solution to use async APIs. And we treat async APIs just like normal REST APIs. So we provide the concept of a self-service in the developer portal, which we call event endpoint management. So where we have a catalog of async APIs, which are in essence Kafka topics that are exposed and that you can offer through a developer portal experience like this to your potential application developer audience. So you can easily see that these topics, like the cancellation one that we're going to use, are actually coming from Kafka. So this is our event streams Kafka implementation with a couple of nice UIs on top of Kafka event streaming. And you can see the cancellations one is actually an incarnation of this topic. But we can easily add another topic to the catalog simply by selecting it through the user interface. For example, let's add the new customers here. We add them as a topic, and then this is a topic that is part of the catalog that is published as an async API and can be used from here easily. Cancellations is the one we are going to use. What we need is to export the async API spec, which I've already done, and I just did it again. So it's available. I can use it for my demo use case, and we can add it to our, let's say, comprehensive Multiform API catalog, which already has REST APIs, GraphQL APIs, and now we're going to add a async API here. So similar exercise, Open APIs 2 and 3 spec. In this case, we are after an async API. Let's just add the spec, which is the cancellations one here. You step through it, and then essentially it is just another wizard piece. You can add some information you like imported from event endpoint management, so you can nicely see what's going on in your API estate and where things are coming from. And eventually we've added this API here as well. All right. Next thing would be, again, to publish it so it is consumable and it'll show up in the developer portal at the end of the day. So this would be an async API, a GraphQL API, and a REST API that we've added, that we've wrapped in products, that we could consume through the developer portal, which is based on Drupal version 5, but not part of our demo for time restrictions, but just a bit of a flavor to show you that we have quite native support for different multiform API styles and types. That is most definitely the strategy of our API Connect product.
Second tenet is API governance. API governance is a fundamental part of API management. Without being able to govern your APIs, as we made it easier now to develop a lot of those, you end up with sprawl. You end up with confusion across the different APIs that have been created by your different teams. And we said it at the beginning that Gartner mentioned that we should treat APIs as products. And what does that mean in practice? It means being able to package those products for consumption, publish them to a portal or a catalog where external consumer can browse them and select the product that they want to consume, and giving different versions that we govern of those different products. Similarly to a phone, I buy a phone 2 years from now. I want to be able for my existing phone to work until then. I don't want to be forced to adopt the latest version every time one comes out. And finally, analytics of behavioral patterns when it comes to consumption of our products. Are these products popular? Do I need to make changes to these products for wider adoption? All of that is part of that governance life cycle that is a key element of API management. And that is true not only for creation, testing, and publishing, which is very much focused on the provider side of API creation, but also for discovery, consumption, monitoring, and feedback, which is the consumer focus of that API lifecycle. In an iterative process that makes sure that every time an API is created, it can be made better, or an API product, it can be made better the next time around. We've learned how to do this very well with REST and SOAP. We can do things now like automated linting, which is the ability of defining rules and rule sets coming from specifications like the OpenAPI specification or OWASP, or my custom rule sets for my industry or for my organization, and automatically validate them against my API catalog even before we publish those APIs, so that we know that we're going to put out APIs that are solid, that are secure, and that follow our internal and industry standards. So we've learned how to do that, but we want to expand all of the same capabilities across the entire life cycle, across the automated governance capabilities beyond REST and SOAP, with GraphQL or with Kafka, with async API, as I mentioned. So the key, the fundamental winner of an API management toolset is the toolset that allows you for that API governance to be automated and easily implemented, but also to be used across a variety of different formats, a variety of different protocols, a variety of different interaction patterns, so that I can treat my APIs, now intended as a generic term, my exposed services, in a very consistent fashion, independently from how the data is consumed or for the protocol that has been chosen for that API to be exposed.
The API lifecycle management capabilities to put governance around your API, to version it. There's a whole set of capabilities when you look into the catalog that holds the APIs, for example, and you inspect the products. So the products are the containers that are wrapping one or more APIs into a product, attaching plans, rate limits, etc. to it. And you can see when you evolve those over time, you can nicely version them. You can see if they're published, what condition they are in, and then you have a lot of very comprehensive lifecycle capabilities to, for example, deprecate a product, to retire a product completely, but also more sophisticated ones to replace it with another product or set of APIs, or to do something like superseding, which is replacing the product with its APIs with new versions, but it's keeping up all the subscriptions and the consumer organization that is basically attached to it through the developer portal. So that basically encompasses a whole range of individual functions that are all more or less baked around the user interface here, and you can nicely use these operations as a non-technical person, a product owner, for example, and elevate it. And then certainly there's also all kinds of other capabilities here around the product to change visibilities, the set of APIs in there, view the approval history, etc. So it's a very comprehensive set of API lifecycle capabilities through the UI, but also, as always, everything is available through a command line interface and also through a management API to fully automate it and to provide CI/CD pipelining without using the user interface for automation purposes. The second piece we're going to look at is API governance as a product capability. So when you develop an API or product and you are, let me just open up one here, maybe my Salesforce leads, and you're in draft mode, and basically you have the option to test or to validate the API with specific rule sets. And the rule sets, there's a whole set of rule sets that are provided as part of the product, and there's also custom rule sets. So the description set, for example, is a custom one that I built, but I'm just going to use the IBM headers one, and then on the second page another pre-baked one, which is the OWASP rule set. And then within the rule set, you can select which of the specific rules you want to probe your individual API against. You can validate, and after a couple of seconds, you get a nice report to see, okay, there's 13 notifications and warnings from 13 different rule sets here within the rules, and you can actually see what's in there, where it's coming from the OWASP rule set. That's where most of them are coming from. Missing responses, schema type of array must be including a max items response, just to make it consistent and protect against, in this case, OWASP vulnerabilities. You see which API, which is our local one, and specifically which path, so where you find it in the YAML definition to fix this issue. But you can also batch operate it out of the product itself. And for that, we go into the manage resources. There's an API governance tab in here. And you can see here the different types of rule sets here. So those are the ones that are shipped with the product. And this is one that I created earlier, description set. I think description set is actually quite a useful capability here, because it just checks if an API has a description. You can get so far with naming conventions, but a description is actually something that every API should have, so you can identify, you differentiate, and really work with the APIs. And there's an easy way to build a custom rule set here and rule that you check against in API governance. So that is one option. And just to go back into the resources here, in our case, maybe we validate, and we select this description set in this case. We select the OWASP one, and then the individual rules within the rule sets, and then you can more or less select the APIs you want to test against. So in this case, it is 10. You can click validate. It'll take a bit longer because it's not one, it's 10 APIs in one go, but you get a nice report as well. And that way you have a very nice central capability to check your governance against rule sets that are defined from a central team against your potentially decentral API development entities. And you can see here, yes, there's a lot of notifications, 800 warnings just about from different rule sets here. And you can see what APIs are touched here, which ones have basically more notifications and which ones less. And then you can delve into the individual responses, check it, and go ahead and get it fixed. So you have consistency in your set of APIs for API management.
Number 3 is testing. The importance of testing and automated testing is undoubted. There is a number of reasons why testing is becoming more important. First of all, because as we said a number of times now, there are more APIs out there, which means that manual approaches to testing don't cut it anymore. It's impossible to test all of those APIs out in a manual way, from creating a mock whilst I develop my APIs to develop it in a test-driven development approach to test it once the API is ready. We need to use automation. But the second aspect of why testing has become so important is our consumers' behavior. It's not acceptable anymore to our API consumers to receive an error, even if that error says, I'll try again or come back later. That's got a direct impact on the reputation of the API provider, and sometimes a financial impact, because consuming applications rely on those APIs to always be working. So it's not acceptable not to have fully tested your APIs before pushing them out. So what is a solid strategy to testing? This is where AI and machine learning once again come and help us with this vast amount of APIs that we're producing. Obviously, automation is key. I need to be able to automate the way that tests are performed against my APIs, but machine learning models can help me doing that across the life cycle of that API itself. From using bias random models that help me create tests whilst I'm developing the APIs by simply creating a set of random invocations of that API whilst I develop it in a very test-driven development approach, to using things like natural language processing to interpret the OpenAPI specification, and based on what's in that spec, creating a set of test assertions that can be performed against the API itself. Things like I can see 4 operations, I can see this number of paths, and the payload needs to be in this certain shape, and the return code needs to be 200, and I need to have a response that contains this type of data. All of that stuff can easily be inferred using the OpenAPI spec and can be automated as a set of test assertions that are part of your CI/CD pipelines when you push your APIs from test to the next staging environment. And finally, once those APIs are in production, we should have the ability to take real consumption data and use things like generative AI to expand from that existing data and create a data set that is much wider and has got the ability to cover every functional and non-functional scenario for those APIs. So it's quite exciting to see how different forms of AI come to help in that testing lifecycle.
We are looking at the 2 different options, API test and monitor and auto test assist. Both are very much AI driven to assist you with the exercise of creating sophisticated API tests and running them, but they're inherently different. So we are launching the test UI directly here from the API manager. Click on Test APIs, and it opens up in a separate window. And it's coming back with a whole set of test suites that you can create. That's how it starts with. I already have a couple created. I'm going to open one here. Look at the tests. You can see which are already created. But I'm going to start from scratch when this has opened here, just to use the HTTP client, for example, and yeah, just import a specific call against one of those APIs. Send it off. You can actually see what's coming back. This is a pet store API. That's actually quite known with a bit of feedback, and you can see that you can start generating the tests from this end. You can give it a name. Get pet is the operation I'm using here, and I'm selecting my test suite here, and then just let the tested monitor do its magic, because it's going to generate the test assertions. It's all set now, and you can see you get a whole set of assertions here that are pre-baked based on the OpenAPI specification that it's releasing, or based on the calls that you're making. And the bottom line is, the more qualified your specification is, the more test or sophisticated test assertions you're going to get out of this tool. And you can obviously start and add requests and add assertions here of different flavors to make it complete and comprehensive. But it's a tool that lets you save a lot of time in building these. So I can go ahead and save them away. And then as a second step, when I'm back in my test suite, I can publish the test, and then I can run it. I can automate it, and I can see, for example, when I go to the list of tests here, that I can start a run of this one here, and you can wait until the run is complete. It is successful, and you get a full report to see what's going on here. So it was not a sophisticated call that we're testing, a subset of that API, but you can see the assertions have all been satisfied and have been called off. And that's more or less how it works then at the end of the day. And bottom line is, again, you can integrate this into your CI/CD pipeline, so it's not meant to be run necessarily out of the UI. You will automate this as part of your build and deploy pipeline for the AM API updates. The second piece I'm going to show you as a video for the time restrictions. That is the Auto Test Assist application, and that is actually something that goes from the same test suite. We're going to look at the list of tests here. The test cases, there were none in here, but you can add so-called test profiles. And here you feed it an API specification again. So in this case, it's the bookshop API that was already uploaded here. It actually creates a profile for that specification and a whole list of API extensions. So this is sophistications, qualifications of the API to give it an indication of what tests are going to be run, because you're not creating individual assertions here. This is a profile, and that is consistently run over time and doing a range of different calls. But you have some control over it, so you can start configuring it with simple things by giving it a different or specific server URL. You can limit the number of requests that it's doing, and you can do some other things like prioritize specific operations to target on when running these tests. You can see them here as an example, and then at the end of the day, you will just, and you can add security, you can authenticate obviously in different flavors, and last thing, you would just save it and run the test, and after a while, and I've just started this here, you will see it's generating calls. You can see how many it's made so far, how many failures in there, and it's just a timed run that you let this hit your API. And it is very much driven by AI and autonomically setting your results here. So you can go over and look at the report. You can see what paths, what calls have been made. You can go into the details and really see what request and response has been sent and coming back, and why specific errors came back on specific API operations here. So this is an even more advanced mechanism in the sense that it's running autonomously just by itself, using a random biased model to generate these calls and to evolve the calls based on the previous call. Very sophisticated way to consistently test your APIs.
Observability. And I said it before, observability is different from simple API analytics, which is obviously important but not enough, and from monitoring. And that's because it's very hard to go and fix something that we don't have full visibility of. And whilst API monitoring has been helping us for quite some time now, observability is much more than that. Monitoring focuses on telling you what went wrong. Observability gives you a number of additional tooling or capabilities to tell you why that thing has gone wrong. So it's really focused in automating and aiding what we call root cause analysis, so that whenever there is an issue, it's very easy for you to identify it and solve it in a lower time, min time to resolution. What are the various components that make that root cause analysis easier? Well, there is a variety of them. One that is particularly important in API transaction is tracing. And for that tracing to be able to go across different components, not only the API proxy, and to be a set of data that is provided in a way that is as low touch as possible without having to go through a massive amount of instrumentation of your systems, so that you can start from a REST invocation of your API and trace down each of the steps of where that API transaction gets executed, from what's happening in the gateway or what's downstream from the gateway, in this case, an integration service running in an integration engine that goes and puts a message in a queue manager. And for each of those steps, look at the code that gets executed in that different runtime that is part of that transaction, so that if there is an issue, you can identify the single line of code that is the cause of that issue, making that root cause analysis much, much faster to achieve.
So looking at API Connect, here's the API Manager, and there's a specific tab for API Analytics, and that already shows you the different dashboards that we're providing out of the box here against our analytics service, which is monitoring more or less the gateway that is hosting the APIs. So there's a more general API dashboard that gives you response times, average response times, the total number of calls, and API calls per day. So this is on a more generic level, and you can switch the context and maybe just envision this in the context of latency. So a latency dashboard that gives you different response times in context of the total number of API calls. And you can always get additional information by hovering over these individual widgets that we provide and look at the usage specific capabilities. But there's also product specific dashboards. This one nicely shows you, maybe from a product owner perspective, how well the different products that are wrapping one or more APIs are ranging and are going. The total number of products, I mean, this is a demo system that has not such an extensive deployment, but you can already see certain trends of API calls per day, the split of the applications into different plans, etc. here. And that way, basically, it goes on, and you can, drill into many different options here. Usage dashboard to see how individual APIs are going, and get KPIs and widgets around that. You can also build your own dashboards and extend it. You can filter it down additionally if you want to have a different context here. So it's quite a flexible framework you can use for API analytics. But you can also use API analytics just simply to offload the log data to your own maybe corporate standard like Splunk here to do your analytics in an own platform and not use the visual capabilities in here. There's also a discover capability that lets you nicely look straight into the log messages that are happening on the gateway without, again, providing direct access for the API developer to that. And this is a nice means to enable the API developer to get more insights into what's happening when he's building the individual APIs here. Okay, next one is Instana. Let's just hop over to the next tab. This is a broader observability tool that monitors all kinds of applications, infrastructure, Kubernetes specifically, events. So lots of information that it's aggregating from your entire estate and deployment. We want to look specifically at our integration platform. So you can see here on the entire integration stack what's happening regarding calls, errors, latencies, issues, and processing times. For our exercise, we are going to look for a specific service here, which is a payment API. That is actually a payment processing API here. And getting the same context out of this one. And when you look at the different, or flow is the one I was looking at, the different flow, you can actually see this is an API that is not only sitting on your API gateway, the Data Power API gateway, but it's actually calling an integration flow on App Connect, and that integration flow is reaching out to a queue manager on IBM MQ to put messages on there. So it's a post-enabled API, and that goes through your entire stack. And therefore, this information is actually quite vital to see how the processing times are, where you have latencies in the stacks, if there's any error messages specifically to one of the components involved, or log messages, or anything specific to your infrastructure here that is monitored or unmonitored. So Instana is a broad, very powerful observability tool that gives you a high level of granularity and a nice way to monitor APIs for observability, but much, much more.
And finally, security. Security, again, is an enormous topic that we won't be able to do justice to in just a few minutes. But it's true that API security has become an integral part of IT security concerns today. Just in the past 12 months or so, more than 80% of a security officer reported API security incidents. And across all cloud incidents, 2/3 are to be attributed to APIs and to wrong configuration of APIs. And it's not only Gartner that says it, but a number of different analysts and industry players out there are convinced that APIs will be the most widely adopted attack surface or attack vector for IT security incidents or IT security threats. So as we create so many more of these APIs, it's harder for us to secure them. It's harder for us to control what they're doing, and then it's much easier for malicious players to leverage them for what those APIs were not intended to do. And the advent of generative AI is only making things worse, because that's although it's something we can use for testing and for development, it's also a massive aid to hackers that can use this new vast amount of data to make their threats more sophisticated. Why traditional security when it comes to API is not enough anymore? Well, we're very good at traditional security, first of all. We're great at doing things like penetration testing, having gateways that are immensely secure, preventing things like denial of service attacks, creating policies that we can enforce in a very fine-grained way to stop attackers. But what's happening is also that with the advent of microservices, the perimeter of our applications are blurring, and we're using APIs internally to our applications for any source of communication. And if something happens, like those APIs get wrongly put on the outside network, or there is a different network configuration that makes them pop out outside of the organization, or simply if I have a potentially malicious attacker within the organizations, then all of these new APIs are a potential attack vector. And sometimes we don't even see what those APIs are unless we explicitly tell people to go and put on a massive thousands of entries spreadsheet all of the new APIs that are creating. And we cannot adapt dynamically to potentially malicious attacker trying to leverage those APIs. So advanced API security is about a number of things. First of all, it's about visibility. It's about discovering all the APIs across your estate. And this is not static service discovery in which you register a service into a catalog. This is about dynamic discovery of new APIs that are laying around your network and that we can find out about. It's about assessing the security posture of those APIs against internal rules or external rules like OWASP to give you a view of how exposed you are to potential malicious attacks. And finally, it's about understanding consumers' behavior in order to identify attacks as they occur and to create remediations to those attacks in as fine-grained manner as possible, to the point of maybe stopping one potential attacker due to their behavior by using their IP or their token without having to take down the entire API or shut off the entire gateway. So those three things are the key tenets of API security. And that's across the lifecycle. It's not only about how we develop and manage our APIs, but it's very much about using information around that behavior to secure single endpoints against single attackers.
So this is the dashboard, welcome page of No-Name API Security. It provides you the core information by critical keys, by different categories, and also organized by the top 10 OWASP API securities from the current year. And we'll start looking at the inventory. So No-Name API Security provides you a nice way to build an inventory of your existing API estate by different API hosts and APIs. You can see the core values here by numbers, by different data types that are running through your estate, the type of API that you're using with different technologies. You can see those are also the pieces that API Connect nicely or natively supports, and different API authentication mechanisms and classifications that you can see here. If they're internet facing, if they are internal, if they're unused for 60 days, for example, which might give you an indication to not expose that API anymore. And then certainly you can drill down into the list of APIs in your inventory. So this is rather a comprehensive view, but you can filter that down to specific APIs, for example. And then you get a lot of information that an API is not just an API, but it's a combination of a host and a specific path that is analyzed with the API method, the authentication mechanism, which is important, and also additional things like the data type used, etc. So you can specifically click on any kind of operation here from an API and get further insights. Also, it's obviously a learning phase, so it needs a level of learning to really get a 100% view on a specific API. That's by monitoring the real-time traffic that's happening on your system. So if you look at one of these APIs, you can see which parts have been fully analyzed and which ones have not. Obviously, the authentication by JWT token has been analyzed, but a couple of things just need a bit more traffic to get through all the findings and incidents and the full API specification. So a lot of metadata is being presented. The technology, as I said, the API type, the risk assessment here of an individual API, and then obviously some statistics, the average number of requests per hour, etc. All these insights you gain easily and also dynamically over time. So you can see what changes are happening if new APIs have been added. if just specific pieces like the a header has been added, and those schema changes you can see nicely in context of the list here, and highlighted directly to you. So very direct and useful insights to see what is happening in your system there. Going back to the actual security, I said it's categorized by different severities, by the OWASP top 10 vulnerabilities. And we can go ahead and drill down into these a little bit more in the findings tab. So they are, the different postures here are categorized by criticality, for example, and the type of violation that is happening here. So you can easily, for example, open up a category and pick an API that is this one here that is violating the data policy. You will obviously get the relevant information, the attacker information, where it's coming from, certainly. You can start blocking them by IP, or even if there's more information like the authentication token available, you can make a much more comprehensive blocking algorithm and secure your API state that way. And yes, you can always take action and see what actually the problem is and get explanations here, and see the evidence, which is quite important. So in this case, you can see, I believe that there's a data policy violation. I think in this case it is the, but you can't see it right here now. But in another example, you can see that the password has basically been sent as part of the XML, and it's not encrypted, and that is not a valid data policy approach in this case. So that brings you down to the individual security violations that you can see here and drill down. But you can also look at, for example, a view of the attacker. So the individuals that have been, or IP addresses that have been identified. Again, you can start blocking. You can create an allow list, and you can actually see what specifically they've done, what kind of attacks, and what attack information is available here. So it's quite granular and quite comprehensive to secure your API state, and not just over your single data power API gateway, but it's actually technology that goes across vendors. If you have a multi-vendor strategy there, No-Name provides you a single view and inventory of your API, and comprehensive measures to assure advanced API security.
All right, in IBM, we're very excited about all of this because across our API-led integration portfolio, which is made up by IBM App Connect and IBM API Connect, we are able to tackle a lot of those tenets and what's behind those tenets in a way that is pretty enterprise-wide. From being able to use low-code, no-code, and machine learning-aided tools to create APIs, to govern them across the life cycle in a way that is as automated as possible, to have testing that is augmented by machine learning and AI that you can embed in your CI/CD pipelines, to use IT observability tools for API observabilities and aid root cause analysis when an API incident occurs, to do API advanced security together with static API security at the gateway level and dynamic API security for discovery, posture management, and behavioral analysis of consumption. API Connect is our lifecycle management product that has been there for quite a while and is extremely successful at what it does. But we've augmented its capabilities with a partnership, a global partnership with a company called No-Name Security, which is all about dynamic advanced API security. And we've recently acquired a company called StepZen, which is all about declarative creation of GraphQL APIs that then get managed by our API gateway. And we're pretty proud about the work that we're doing. We've been in all the Leaders Magic Quadrant by different analysts for the past 7 years as the top right representatives, the leaders. But we also like to think about API management as not only a set of features and functions, but very much about a set of tools to implement real life use cases. And that's where we shine at. It's not really only how many things we can do, but how easily can we help customers implement a multi-experience architecture or integration using their APIs, or doing things like open banking, open retail, you name it. It's about what you do with those features and functions. Well, if you're interested about knowing more, there is much more that we've learned across the conversations with customers in Asia Pacific and around the world. There's much more that we're doing in the toolset in our strategy to facilitate reaching success when it comes to API management. So reach out to us, come and talk to us. We'll be happy to take this conversation further. Thank you very much.